Right, good evening everybody. Welcome to the second lecture in the 2020-21 Railway Division North Eastern Centre programme. My name is Louise Shaw, I'm the Centre Chair this year. I hope you've all had a good September. It's nearly over, we're nearly into October and the night's going to start drawing in. So it's a good opportunity for everybody to take in some new lectures on subjects they know, subjects they don't know, and the Railway Division has a programme which hopefully should support everybody's tastes in that respect. So on the screen you should now see a list of all of the Railway Division's events this October. Some are in the centres, and there's a seminar that is being put together by the 4 Railway Professional Engineering institutions. That seminar is still open for registration. It's the Automation of Railways seminar, and after this lecture you should find in an email to all of you who are attending tonight the link to how to register for that seminar. But you can see there's also a variety of other events, some of which are deeply technical, such as systems integration and engineering, and others of which are somewhat less technical and more general, but there should be something there for everybody. All of those lectures are open to everybody, so there's no geographical limitations because of our virtual programme this year. We also should have been able to send out to everybody who's registered properly programme cards for the remainder of this year. If you haven't received your programme card, could you please check your profile on IMechE.org. You have to select Railway Industry and to select Receive Updates by Post in your profile in order for that to work. If you've not received it, my apologies. We can still send you a PDF, I hope, and I'll be organising that the next day. And there's an email on the next slide which you can use to send me a request if you haven't got it. So we've got several communication mechanisms for you to keep track of what's going on. You've got the Near You page dedicated to the North East Centre. There's a Railway Division web page, an IMechE events page, there's a LinkedIn group specific for the North East Centre, and that email I just spoke about, rdnortheast@imeche.org. If you've got any communication challenges, please use that. Or you can find on the Near You Centre, there's some contact details for all of us. So that's the parish notices over and done with. Now some quick technical advice on using Workcast, the programme that we're using to support this lecture this evening. You should see on your screen a tab or button marked Ask a Question. That's your means to get any technical support from Emma Pateman, who's our IMechE help this evening. And that's also the means to put any Q&As in, or any questions that you'd like to ask our presenter this evening, which we'll handle at the end of the lecture. If you type your question in that box, please do identify who you are, especially if you've used some kind of pseudonym when you logged in. Your question won't be visible to the rest of the audience, but it will be visible to me and to our presenter this evening. I'll compile the questions and then put them to our presenter, who's Neil Blagburn. You can adjust the screen size a little bit if you want to. That's up to you to set what you're comfortable with. And one further thing is that our speaker this evening has kindly agreed to having the lecture recorded, so you will all receive a link to it following the lecture as well. So don't worry if you miss something, you can catch up with it afterwards. So tonight's lecture, the subject is the new fleet being bought for the Tyne Wear Metro, being built by Stadler. It's the second lecture we've had from Neil Blagburn on the same subject in the last 18 months. The last one took place after the bids had been submitted, but before the winner was known. So this evening's lecture should bring us right up to date on the new trains and the transition from the old to the very new. Tonight's speaker is Neil Blagburn. Neil is an experienced and accomplished project management professional with 17 years experience in delivering high-profile, complex, multidisciplinary projects in challenging railway and construction environments. But he started out with some humble beginnings. He was an apprentice fitter and undertook various roles in rolling stock engineering and infrastructure engineering before pursuing his career in project management. He's now the programme director for a £700 million investment programme that will transform the Tyne Wear Metro system through the replacement of the fleet that he once used to maintain. So, without further ado, if I could hand over to Neil, and as a reminder, we will take questions, but we will handle them all at the end. Please put questions to Neil. It brings more insight to everybody, so the only dumb question is the one that doesn't get asked. Right, Emma, can you set up Neil's slides, and then it'll be over to you, Neil.
Thank you, Louise. Hopefully, Emma can confirm that the first slide is on there, the title slide, and everybody can see that. I'm trusting that you can, and I will proceed. So thanks for the introduction, Louise. This presentation does bring us up to speed with the fleet replacement programme, and as you rightly pointed out, the last time I spoke to this group, it was before I could say too much about the new trains and the successful tenderer, who we now know as Stadler. So I can say a lot more about those trains now, which everybody will be pleased about. Before I do, I'll just remind everybody what the fleet replacement programme is all about. Obviously, a manufacture and supply of a new fleet of trains for the Tyne Wear Metro, the long-term maintenance of the new fleet, and also the maintenance of the existing fleet in there as well. Provision of a purpose-built maintenance facility for the new fleet, and construction of a satellite depot to facilitate the main depot reconstruction. So total value of that investment is around 700 million, as Louise pointed out. So a hugely significant investment for the Metro, and a hugely significant investment for the region as well. So this change program, that it is not just an engineering program but a change program, is going to be transformational for our business in the region in which we operate. I'd also like to remind you of the contract overview. It's been a while since I did talk about the contract structure that we have. The main contracts are in orange, and the lighter colour in between the orange ones, the depot construction contract, the DCC, the Metro Car Maintenance Agreement, the MMA, the Train Services Agreement, which is the TSA, and those are the maintenance contracts for the existing and the new fleet, and also the Manufacturing Supply Agreement, the MSA. So those are the core agreements, and we entered into those with a single entity, which we now know is Stadler. And in February 2020, after an 18-month procurement process and another 6 months getting our final business case approved by the Department for Transport, we all met up and signed contracts on the quayside, something which wouldn't be able to do today, and only able to meet, shake hands, and leave the house today, unfortunately. But we managed to squeeze that in before any lockdowns in March, so that was good. The real reason for all of those agreements being with a single entity was that we could get a train which the maintainer was happy with, and that took on board the maintainer's observations in relation to the train design. Similarly with the depot could be made fit for purpose, aligned, optimized for the new trains, and the depot could be optimized for the maintainer. So those connected agreements with a single entity ensure that you get that, and that nobody's skimping and cutting corners on the depot just to save a buck here or there at the cost of the poor maintainer who needs to go on and maintain those trains. So these connected agreements, which was a complex set of agreements, they all relate to each other. They all have cross references and sign off between the different parties, the maintainer, the depot constructor, and the manufacturer. But it is really going to pay dividends and get us a solution which will be optimised for the maintenance of the new trains for 35 years. Without further ado, that's what you've all been waiting for. Unfortunately, I suspect this isn't a spoiler, because hopefully, with a little bit of luck, you've been having a little look of the trains of your own accord, and the design there. Hopefully, you've seen that in the media splashes that have been around in the last couple of weeks, and also through the research and consultation work stream that we've been undertaking with the Open Lab at Newcastle University. And if you click on the link, metrofutures.org.uk, and the presentation will be available, as Louise said, after the presentation is conducted today. Click on the link, that will take you to a website which is at the bottom of the slide there. Looks just like that. There's a configuration tool in the middle panel there. Click on that, register yourself, register your interest, and design yourself an interior of a train. So this is a consultation exercise which will truly determine through the customer's preferences what the interior of the train will look like in terms of the finishes and the positioning of all the handrails and the cycle provisions and things like that. So this is true consultation, that it will deliver, you know, the preferences from the customer that we then take into the final designs and manufacturing. Give you a little bit of technical data on the new fleet. So the 5-car articulated units, we have 4 motor bogies sandwiched between 2 trailer bogies, which we think is an interesting configuration. Each axle on the motor bogies motorised, and around 60 metres in length, just shy of 60 metres in length, 2.65 metres wide, fit inside our network. Weight, we're still restricted on our network at 12.5 tonne axle weight. That's fully loaded, of course, and that's something that the new trains conform to. Height above rail 940, and the sliding step, which we'll like to talk about with the new train design, which I'll come on in just a bit. So the sliding step, height above rail 910. 80 kilometers an hour, so that is the service speed. I think the trains are capable of going quicker than that, but at this moment in time, the network is still constrained to 80 kilometers an hour. So in future, perhaps we can look at stretching the speed limit a little bit higher. But effectively, it's a light rapid transport system. So it's these metro cars aren't going to get up to any high speeds, but certainly they would probably be capable of going a bit faster than 80 kilometers an hour. 600 capacity on the trains. That is about 80 higher than the current equivalent train. So we think that's really good for our customers in the peaks. If we ever get to crush capacity in the peaks, it's hard to say it at this moment in time, but I'm sure one day that'll come. 1.3 gigawatts of power and 140 kilonewtons of traction force. Acceleration limited to 1 meter per second squared, which ties in with our system and signalling arrangements, and also passenger comfort as well. So moving on to some of the features in the fleet. Said before, we'll talk about the sliding step, and this is something that we're really excited about. So the sliding step that you can see coming out from under the open doors there on the side of the train, that will truly close any gap between the train and the platform, and this is one of the things that helps us achieve full of our compliance once our new fleet is in place. And we'll be really proud of that, because there'll not be many out there that achieve full of our compliance, and in particular the all important gap and height distance when stepping on into the train from the platform. So this is one of only 2 fleets that I'm aware of, certainly in the UK, that will have this technology deployed. The first one to deploy this will be on the Mersey Travel Network, and the second will be us. So we're really, really pleased about that. Interesting, you can probably just make out around on the inside edge of the right-hand door leaf, you can see a green strip. That is actually a light. It's a green LED strip. It's a halo that will go around the doors, and that halo will light green when it's safe to enter and depart the train, and it will flash red when it's not safe to depart the train, i.e. when the doors are closed. And so you will be aware of trap and drag incidents around the UK on different networks, and this is a risk on our network just as it is on others, and this is something that we really liked with the Stadler design. Really put some thought into that platform train interface, and passengers in and around the door areas, and this is a fantastic feature, we think, of the new train design. We'll have an onboard energy storage system. So from day one, we will be able to get ourselves out of trouble if the overhead line fails on the network. So we think that's something that we should really do in the 21st century, and it's something that we will be doing with the new fleet for certain. Interestingly, the energy storage system is also from the off being designed to be capable of expansion. So building on that system to increase the capability and the distance of the trains, and this ties in with our route extension aspirations, and it's a feature that will allow us to reduce the cost of any extension, by removing the majority, if not all, of the electrification within a route extension, and that will drive out a huge amount of cost in electrifying a new bit of a railway, and increase the benefit to cost ratio. And when you're competing for finite sums of money, usually from the government and sometimes from other sources, it's really important to drive up the all important benefit to cost ratio and prove that your scheme is more worthy of investment than somebody else's. So I think that probably gives us the competitive edge compared to other schemes. Pantograph and overhead line monitoring system. I know there's other fleets in the UK have this system. We certainly don't at this moment in time. So what we do every time there's an overhead line incident is spend a disproportionate amount of time arguing between the infrastructure maintainer and the fleet maintainer as to whether or not it was the pantograph or the overhead line that caused the issue in the dewirement. So this POLEM system on the new trains will eradicate that, and it will also hopefully solve the issue of dewirements by predicting the failures early enough on in the development of faults, so we can send somebody out and rectify it before the wire comes down. So this is certainly the aspirations for the POLEM system, and it's certainly within the technological capabilities of these systems and clever algorithms that exist within them to detect faults early on within the overhead line system and of course the pantograph, and flag those to the maintainer through their various systems. Next point is do CCTV, so that's the driver only operation, of course, and we only operate with drivers, we don't have guards. And the CCTV system currently where we have it is on the infrastructure. We also have vast majority of the infrastructure has platform mirrors where the driver looks at the mirror, gets a view down the side of the train to safely dispatch the train. The new trains will have CCTV over the doors, so you'll be monitoring the monitors within the driver's cab, and the CCTV images will be a lot clearer, allow us to dispatch safer than we currently do from the mirrors. Not that it's an unsafe dispatch at this moment in time, but You have challenges with weather conditions where mirrors can ice up, despite the fact that they're heated, still ice up, fog up, CCTV on the infrastructure, reliability issues with that. So moving forward, we will resolve all of those issues with having CCTV on the train. And then if there is an issue with any of the DO equipment, then hopefully it is isolated to one train rather than more widespread, so you'd still be able to continue operating a reasonable service despite that. From a radio systems perspective, we've got GSMR and Tetra radio, so a dual radio. So well, it's a dual fitment of two radio systems within the train. GSMR obviously for network rail infrastructure, and the Tetra radio, which is what we have installed on the Nexus network. And over time, we envisage that we'll go for a unified radio system when Network Rail update GSMR and roll that out in our region. We'll tag on the back of that and get our system upgraded at the same time, upgrade our infrastructure and to just go for a unified radio system. We'll have passive provision for ETCS. That's sometimes a question that comes up in presentations, and certainly came up at the presentation I gave a couple of weeks ago. So I thought I'd add that one in. So yes, they will be ready, and we will be able to fit them out at whenever the ETCS is required between Pelo and South Hilton in the northeast of England. Real-time condition monitoring. This is fairly standard these days, but certainly when you're dealing with 40-year-old trains, it's very, very new to us in Nexus. So getting data from the trains and being able to diagnose faults and issues before things fail and before you have to take trains out of service, that just sounds fantastic. It's all about improving the reliability and keeping the trains out there for our customers. So this really gives us that edge there to do that. And also it feeds into real-time information as well. So we can push out data to our customers, and perhaps through apps over time we'll be able to get our customers to report faults as well. So two-way street there, feed them information and they can feed us information. So quite often the customers are the first people to know that there's actually an issue occurring. So that would be fantastic if we feed that back into our system. So the new trains unlock all sorts of possibilities around that, which are fascinating. Mainline crashworthiness, don't think I need to explain much about that, but certainly the existing trains don't have the level of crashworthiness that the new trains will have, and that opens up possibilities to remove any special signalling arrangements that we have currently on Network Rail infrastructure. And last bullet point on the list, AVIS. So this is the automatic vehicle inspection system. It's not on the train, it is within the depot, as the bracket suggests there. We're really excited about this because this is something that will really hone our maintenance over the life cycle of the trains, and make maintenance more targeted. So trains will pass through the AVIS system, which is the best way of explaining that without a picture. It's a portal. It has cameras and laser measurement equipment, and it will detect differences within the train and be able to undertake measurements. So brake disc, brake pad thicknesses. So rather than sending somebody in under a train with a micrometer or a vernier, here we go. The laser measurement system does that for you, and it uploads all of the data to a person sitting behind a terminal, and then they can digest that and raise the maintenance requisitions to the teams as and when they need to. So rather than deploying maintenance asset to look at a lot of things that don't need maintenance, we don't do that anymore. In the future, we will just be sending somebody under a train because something needs to be replaced or tinkered with. So we think that is absolutely fantastic system, which is going to pay dividends over 35 years and go to a condition-based maintenance regime as opposed to a planned preventative maintenance regime where we find ourselves currently. And I'd love to say a bit more about the trains, but even within an hour, this presentation may be a challenge. So I will move on. Some photos there of the existing driving cab at the top, and the image of the new driving cab below. So a picture says 1,000 words, so I won't say 1,000 words, but certainly you can see that the existing cab, which is about the size of a telephone box, we're given the drivers a far more ergonomically designed space, moving to a centralised driving position as opposed to the left-hand driving position that we currently find ourselves, and that wrap-round desk where everything's at the fingertips. And we're currently consulting on this at this moment in time through virtual reality, and all of the drivers, with very few exception, are really impressed with the new layout and the new cab design. And interestingly, the virtual reality technology was something that we were sort of pushed into with COVID. Back in March, when we were talking about bringing in cab mock-ups and physical mock-ups of the cab to consult the drivers with. The lockdown happened, and then it was a thought of, can we really actually pull this off with getting a mock-up and encouraging large volumes of people to go through it, and then what do you do about cleaning everything down afterwards? So the suggestion of going virtual was muted, and we just jumped on that straight away and said we really just need to make this work to meet within the timescales. So we've got virtual reality equipment set up in the control centre at Gosforth, and we spent the last 3 weeks consulting our drivers as and when they pass through the control centre. They pop in, they put on the virtual reality goggles, they hold the ones there, the photo in the top right, and effectively it's an immersive experience for the drivers, and they have been providing us with feedback on the designs. The beauty of the virtual reality technology is that you can undertake changes to the design literally at the touch of a button. So within days from a driver giving us feedback, we can change the virtual reality model, upload that to the equipment that we have in the control center, and then the drivers have got the changes built into that model that they suggested only a few days ago. And we just think that is absolutely fantastic, and something that we wouldn't have been able to achieve if we hadn't have been pushed down the virtual reality route. You couldn't have kept up with the changes on a physical mock-up of a cab, and indeed, those changes would be messy. Once you start drilling holes in bits of formica, etc., to make those changes, it just wouldn't give you the same experience as we have with the virtual reality model. So that is one of the fantastic things that's came out of COVID-19. Moving on to the depot. So the depot, a few images there, served us well, served many people well, nearly 100 years old. So definitely dates back to the days of steam. And I think I've explained in previous presentations, we undertook some analysis on whether or not we should make the existing depot good for the new trains and undertake refurbishment of the depot as it is, and we just pushed that to one side on the basis that by the time we'd started picking away at the rust and the wing had fallen off, and then we had to replace it anyway, you would end up just reconstructing the depot in its existing place anyway, but it would cost you more money than you'd ever envisage, and you would spend more time doing it. So what we decided to do was flatten the existing buildings, which is sad in a way because it's part of the region, part of the heritage, but ultimately the cost and the time involved in trying to do anything else was gonna far outweigh any benefits you would get from doing that. So a new depot on the same site is effectively what we are going to do. So flatten the existing buildings, but build on the same site. That's an aerial image of the existing depot. Funny enough, I was going to replace this with an image from the Google Maps, but when I looked at the image on Google Maps, there was very, very little difference between the image that the architects produced for us and the one on Google Maps, so I just stuck with this one. So that's the existing layout. The buildings to the north of the site, and the stabling, the majority of the outer stabling roads to the south of the site. So that's kind of the orientation, if you keep that in your minds. First bit of depot reconstruction takes a nibble out of the southeast corner of the depot there, and that makes way for the footprint for the new building. If you look in the title of the slide, the stages of depot construction are in there, and you'll note, if you've got a keen eye, that I miss a few stages along the way, and that's really just to fit the presentation at the time scales tonight. And there's some subtle changes within some of the stages as well. So I've jumped a couple of stages, but I will talk you through nonetheless what we're up to. So we take that footprint of land, and you can see that where ordinarily we would stable trains within the depot, where that bit of land is being prepared, we can no longer do that. So that is principally the reason why we have constructed a satellite depot in Howden, just to make the stabling space, or remove the stabling space from the Gosforth depot and create that elsewhere, i.e. in the Howden depot, and that allows the construction activities to exist within the live operational depot. So that's the other point, of course. This is still going to be a live operational depot throughout this construction sequence, and that's worth bearing in mind, because hopefully people can relate to that and understand some of the challenges that we're going to have in reconstructing the depot over a 4-year period, whilst still getting trains out and picking customers up on a daily basis. So the next stage, magically, our new maintenance facility appears in the southeast of the site, and we take a little bit more of the existing running shed to the south of the site as well. And there's a new wheel lathe building at the south of the site popped up there as well. So all in all, just over a year to construct through to that stage, and quite an ambitious program, but achievable nonetheless. We've stress tested this through the procurement, and we're pretty happy and comfortable with the proposals. But it's still, as I said before, going to be an almighty challenge, when we still need to keep this depot operational at all times as well. Next stage, you'll see I've jumped to stage 5. So the next stages are really concerned with removal of the existing buildings within the depot and installing new infrastructure and stabling facilities within the depot, moving towards the north of the site all the time. The older building to the north of the site, hugging the trees, that is the heavy maintenance shop and annexes, and that is the last building to go. So that is, at this stage, what I should also have said is, at this stage we are also transitioning in the new fleet, and the old fleet is departing from the network. So this is where this transition starts as well. So you need the heavy maintenance facility for the existing fleet until the very last Metro car goes. That's when you need that heavy maintenance facility in place till, and you can then think about disposing that once the last of the existing fleet goes. And there it goes, and replaced with some infrastructure for stabling, and that's the impression of how it is going to look in well, how many years? 2021 next, just over 3 years. So quite an ambitious project to reconstruct that depot. I'm sure everyone will agree. It's a £70 million investment, which we'll get to on the next slide. And as I say, about a 4-year construction program to fully complete that and get it handed over. The images there that you can see, that gives you a little bit more of a flavour for what it's going to look and feel like. The final colours haven't been decided yet, so it looks rather vanilla at the moment, but I'm sure you'll all agree that it's lighter, it's brighter, it's a modern maintenance facility. It's optimised and purpose built for the maintenance of the vehicles. And as I said earlier on in the contract structure, we've made sure that the maintainer is signing off on the train designs, and the depot constructor is signing off on the train designs. It's all interrelated, making sure that at the end of the day, the maintainer can turn up into the new depot. Everything's where it needs to be, everything's where it should be, and their maintenance practices and processes can be optimized. So I said a little bit about the satellite depot before and the reasons why we needed that satellite depot. This was again another ambitious project that we needed to deliver in advance of the main contracts being awarded, in advance of the main contracts starting up. So we identified an ex-landfill site adjacent to our railway in Howden. So we looked all over the region, and this was the one that came to the top of the list in all of the assessments to best meeting our needs. So good rail links with us, right next to the main line, and also good road links as well, just off the A19 in a nice dual carriageway there. So that's all important, because we need to think about the delivery of the trains and whether or not the trains will be delivered by road, and also the disposal of the existing metro cars from the site to the local scrap merchant and getting rid of those off the network. So we need to think about those road links for that purpose. So in just over a year, we turned that field that you've seen on the previous slide into that, which is a rather attractive looking layout of a depot if ever I've seen one. Everybody in the business who have visited the site are really impressed with this site, and it's hard to think otherwise when you're coming from a 100-year-old facility and you see something which is nice and bright and modern. And that is a fantastic achievement to construct that within 13 months. £20 million investment, so not a small investment by any stretch of the imagination, and certainly something that we'll be probably looking to keep hold of. It's a question that comes up time and time again when I present on what's going to happen to Howden once the fleet replacement program's finished with it, and unfortunately I still have to say there's a question mark on that, but it's certainly something that will feature within any of our plans for route extensions and expanding the fleet. You may have heard that we are going to award call off an option with Stadler for an additional 4 trains. So we're ordering 42 trains as part of the standard order. We'll be ordering another 4 trains for a project which is called Metro Flow. So this is track dualling within South Tyneside and rolling out a 10-minute service system wide on the back of that particular project, which is going to be delivered in the next couple of years. And we need 4 extra trains, as I say. That starts to push the boundaries of capacity within the Gosforth depot, and therefore automatically we are already looking at additional stabling capacity somewhere on the depot. Unfortunately, we've just constructed a satellite depot in Howden, so that fits in rather nicely with any future plans. So in terms of timescales, we are there. So we are just about at the end of the interdisciplinary reviews on the initial design phase, and the initial designs will be signed off at the end of November, if memory serves us correct. Straight into the final design stage. You'll see from the milestones below, we'll have an initial mock-up, which will feed into the final design stage. That initial mock-up is going to be, oh, somebody's moved my slide on, somebody's tinkering, unless it was an error. The initial mock-up, we did have grand plans to tour the initial mock-up around the region. However, thanks to COVID, that is no longer feasible, and unfortunately that initial mock-up will have to be shown on a more restricted basis and with specialist user groups only. So we won't be opening that up to the public, unfortunately, and that's one of the reasons why we've went to the lengths we have with the current consultation. metrofutures.org.uk, the website that was on the screen before. We've went to a lot of lengths to reach out to the public, and we've had 10,000 people engaged thus far in the few weeks that we've run that session. So actually, compared to touring a mock-up around the region and parking it on various high streets in the region, I think we've reached out to far more people than we would have got to with a physical mock-up. So that's almost another good thing that's come out of COVID, actually. Final design stage early next year, and then all important design freeze in Q2. So get to around about May for the design freeze, and then we're into the manufacturing phase and commissioning of the trains, of course. And the all important milestone of the first train in the UK around about October of 2022. So that will be delivered by rail for those that are interested. So that's quite ambitious in itself, not beyond the realms of possibility, but why not? We've got a railway, it's connected all the way through to Switzerland. Let's give it a go. So the trains are going to come in by rail through the Channel Tunnel all the way up and get them. I think actually the hardest part of that journey, I might live to regret saying this, but the hardest part of that journey might be actually on our network, because whatever locos are pulling the trains from Switzerland through to the UK won't be appropriate for use on our infrastructure, either due to gauging or the axle weight restriction of 12.5 tons. So we just need to have a little bit of a think about the, if I can call it, the last mile of the delivery there to get the trains up to Howden, which is where they'll initially go for static testing. Type test and authorization, not authentication, authorization. So that takes around 9 months before the first unit will be seen in revenue earning service in July of 2023, a date which can't come quick enough for lots of people in the region. And if anybody's travelled on Metro, I'm sure I'll get a resounding agreement there. So that's the date. Some of the other milestones on there: completion of the depot. Clearly, you want the depot completed before your first new train arrives, so that's a key milestone for us to keep an eye on. And also simulator. So we're going to go for a train simulator, which many operators do these days. But that simulator is also going to revolutionise our train crew training program. So where it currently takes 16 weeks for driver training, the simulator will allow us to reduce that, because you can have more time at the controls within the simulator and simulate events in a more efficient way, and it just cuts down on a whole host of inefficiency within the existing process. Of course, it's only inefficient if you haven't got a simulator, which we haven't got at this moment in time. So all exciting things. And I think that is the end of the presentation. I'm happy to take any questions.
Thank you very much, Neil. It's been really good. So to remind everybody, if you want to put a question in, there's a button on your screen for you to click on and type your question in. If you could type your question as clearly as possible and identify yourself as well, that would be really good. So, first couple of questions have come in around energy management and energy storage, Neil. So we have from Donica Connolly and from John Harding, and they're both around the same lines. So could you develop what you said about the energy storage on board? What kind of range you expect, what sort of storage mechanism is being used, and any ideas on any more detailed specifications?
Yeah, I can. The energy storage system, there was lots of to and fro on whether it was going to be batteries, supercapacitors, a mixture of both. I think it is going to be batteries, and that is certainly what's been rolled out through the initial designs. And it's less about range for the day one capabilities, Louise. It's more about time scales, and I'll explain what I mean by that. So rather than just say an arbitrary range of the train will travel 8 kilometres on battery, we've said what we want from the trains to do is survive an outage of an electrical substation, a traction substation, for 45 minutes. So if there was a 45-minute outage of any traction substation on the network, we want these trains to continue to operate. So the reason we specified a time and not a distance was because different train manufacturers would approach that in different ways, and it wasn't really going to yield apples for apples. We wanted them to model the most challenging situation for them on the network. So depending on gradients, depending on dwell times, turnbacks, all of that to be taken into account in the normal running of the timetable. We wanted them to model all of that and tell us what the most challenging environment was with a substation outage, which substation that was, and then prove to us that the train service could continue to operate for 45 minutes by effectively bridging the section of non-electrified overhead line under its own autonomy. So it's 45 minutes of an outage of a substation is what we've specified, so that it does actually yield different distances depending on where you are on the network. So that's why I can't express it in terms of distance. However, to buck that trend, I will express the day 2 technology in terms of distance, because what we have asked for from the offset is the ability to call off an option for the trains to be the onboard energy storage system to be enhanced to allow us to travel 16 kilometers on a route that was specified and modeled based on a route on our own network. So for those that are interested, it's 8 kilometers short of St James at a point in the infrastructure which doesn't align with anything, including an overhead line mast, but it's 8 kilometers from St James into St James and back out to St James to that 8 kilometer marker. That is the 16 kilometers that we've modelled, and we will be testing that with the first test unit. So the first test unit will be kitted out with that technology to prove to us that the trains are capable of that. And over time, I've said this before, I'm sure, to this group, over time, as battery technology improves, which it is all of the time, we will expand that 16 kilometers to something far greater. I'm pretty confident of that. In 5 years' time, 10 years' time, or who knows where we'll be in terms of capabilities. And that opens up, that begins to open up an awful lot of route extensions, which then don't need to be electrified. Stadler have also partnered up with Newcastle University, and the section within Newcastle University that is devoted itself to looking at research into alternative power sources and battery technology, and that is a partnership which will feed directly into the future of these trains. I'm pretty certain of that. Does that answer the question, Louise? I've kind of rabbited on a little bit there, but hopefully that does pick out the key points.
I think it does very well. Thank you, Neil. I think one other question that might be latent in people's minds didn't get stated was any ideas of the weight penalty for batteries that's on these trains compared with than what might have been through another system?
The weight penalty, we will know that, and apologies I don't have that sort of information rattling around in my head tonight, but we will be able to deduce that. You know, the key for us was to keep the weight under the all important 12.5 ton at the axles. So that was the key for us, and we've achieved that with the batteries. So I suppose the alternative is, if we didn't have the batteries, then we would have been able to strip some of that weight out, and of course, you know, energy efficiency and a whole host of other benefits from doing that as well. But despite the weight going all but up to the 12.5 tons, these new trains in operation will swipe 30% off our energy bill, which is a fantastic achievement.
That sounds very positive, I think. Okay, I'm going to claim chairman's prerogative and ask some of the questions that I want to ask, whilst some of the other questions are coming in then. I recall from when you last presented to us, Neil, the sort of timing around the decision to go for Howden and having to develop a design and a project plan before you really knew who was going to be the new trains builder and what those configuration of those trains would be. What sort of allowances did you put in to your design program to ensure that your depot could actually support the new trains in their whatever their configuration was going to be? Or did you have to make some assumptions and then adapt as required?
So it's an excellent question, Louise, because it certainly was a decision we had to make before we knew where the trains were going to be manufactured and who was the manufacturer was. So I think one of the key issues for us at the time was how long the trains are going to be. You know, when you're designing track layouts and signalling systems, the length of the train is important. I'm sure I don't need to tell anybody on the line here tonight that. So through the market engagement, we specifically asked some questions about length of train, and speaking to manufacturers before the procurement started in earnest, we settled at 65 metres. So this was based on a technical specification that we knew that we were demanding of people to adhere to. We also knew that the trains had to function on our infrastructure, so that sort of introduced its own sort of limitations on how long the new trains could be. So Howden was designed for a maximum train length of 65 metres, and as you can see from the presentation tonight, it came in at just shy of 60 metres in length. So we had some room to spare there. But that was one of the key design considerations, decisions we had to make, because, you know, clearly if the trains were longer than 65 metres, then we'd be in a bit of an embarrassing position right now. As for the maintenance building itself, that was a little bit easier, because effectively we've just made a white box of it and said whoever the manufacturer is and the maintainer is, perhaps more importantly, then if there's any maintenance that you need to do from Howden, then you need to kit it out. I suppose the exception to that is we thought, okay, if they turn up with some jacks and put them on a floor which isn't reinforced, then they're gonna get an incredible sinking feeling when they try and lift the train. So we thought about that, and the floor is reinforced for jacks and also forklift movements as well for any heavy components and materials. So we did think about those sorts of things, but by and large, if the maintainer wants to come and kit out that depot with various things, then they can, because it's effectively white boxed.
Sounds like that's some sensible thought before getting too far down the road. Okay. And sorry, just as a slight follow-up to that, did the pre-existence of it being a brownfield site with what we might say a checkered history how much difference did that make to the construction?
That's a good question. So, two landfills on that site, I think, in the last 180 years, from the records. Well, it was cheap. It was really cheap to buy off the council. But joking aside, the considerations were substantial in terms of firstly, what treatment had been done to the former landfills. So we needed to make some checks on whether that was still holding true. And then, of course, we needed to put in our own arrangements to stop things like gases escaping through the ground into the facility itself. So membrane throughout the entire site. But by and large, the ground stabilisation that were put in there, the ground was pretty good condition actually. I was expecting it to be a lot worse. So once the ground stabilisation went in, once the initial drainage went in to take the water away from the site during construction, it was a pretty clean site in terms of not a lot of soggy mess lying around. It was pretty good.
Okay, well that's very encouraging. Right, so we've got some other questions which have come in from a variety of sources. I think there's a question about going back to the energy point for a moment. If Network Rail, and this is from Christopher Iredale, if Network Rail goes through with its electrification aspirations for the Durham coast, what is the likely outcome for the new fleet? Would you run on battery between Pelaw and Sunderland, or convert it to dual voltage? Or would you progressively convert the Metro itself to 25 kV? For people who don't know, the Metro network is currently 1,500 volts DC rather than 25 kV AC. Where Christopher has commented that's unconventional but could save, being a novel operating system and so on. So if we get a network extension, if Network Rail electrifies on the Durham coast, what do you think your options are?
So numerous. So will Metro trains run down the Durham coast, or will it be a different train that we connect to? So one of the points just to make is the expansion of the Metro system doesn't just involve running the existing fleet of trains to new destinations. That will, of course, feature within expansion of Metro, but it is about connectivity more generally. So schemes such as the Durham coast, would it be Metro trains heading all the way down there? I don't know. Is it more of a heavy rail solution perhaps? I think so. It all needs to sort of come out in the wash really and be properly evaluated. But there are options. If it's electrified to 25 kV, I'm a fan of electrification, but I wouldn't hold my breath for that. I think there's probably other electrification schemes which have got far more backing and a better benefit to cost ratio in the UK that won't be delivered compared with the Durham coast. So I wonder where that would be on the pecking order. But say it got electrified, then we would effectively run on batteries down that region. And yes, it does then cause a challenge on, okay, so can you run all the way on batteries? I doubt it, and certainly not today at today's money. So you would need intermediate charging, and if you can't have that intermediate charging in the overhead line, do you need something within the track and below the train? So you've got to open up all those sorts of discussions and challenges, which then probably puts you back into the realms of, well, is the Metro train the appropriate vehicle to be running down the Durham coast? So it kind of comes full circle. Dual voltage on the trains, that is something that we did have in our specification originally back in 2016, and we approached the the market with a questionnaire, and of course we're talking to the market as well at the time prior to the procurement, just to drum up interest and get some soundings for what it is we're asking for. And it was clear that we're asking for an awful lot. 12.5 ton axle weight restriction, running on 1500 volts DC and running on 25 kV AC. Everything in there, heavy transformers for the 25 kV AC, batteries adding weight, and it was really the straw that broke the camel's back. It was going to start impinging on the interior design because of a deeper pantograph well for 25 kV AC pantographs and the insulation you need there, and we don't have the space above the train to fit it because of constraints on our infrastructure. So the dual voltage was going to cause us a real problem had we continued with that in the specification during the procurement. And fortunately for us, because we thought that was going to not go down too well within the region, because it was something that had been dreamt up years earlier and sort of enshrined in our local strategic plans, transport plans. So fortunately, the mood music at the time wasn't very good for electrification, and I'm not entirely sure the mood music's improved very much since that in the last 4 years. But certainly it's unlikely that huge swathes of the northeast of England, especially some of the older tracking alignments, are going to be electrified anytime soon, and debatable whether they'll be electrified within the 35 years of the life of these trains. So I'd like to be wrong there. As I say, I'm a fan of electrification, but unfortunately we've got to be realistic as well.
I think that's a very good answer, and you've also partially at least addressed one of the questions which was coming from Rob Howard. I think you've effectively answered it in passing, Neil. Okay, just checking the list. There's one interesting operational question in, which I know always is an interesting one for anybody that's getting a new fleet in. Has consideration, and this is from Andrew Frodsham, has consideration been made of how the old and new trains will rescue one another during the transition period?
Pleased to see it has. So it's not. It might not be the cleanest way, but we have specified, and we're getting coupler adapters, so the existing Metro cars can couple to the new trains. So they are different couplers between the two, and we'll have a coupler adapter where you could recover either or in the event of a failure. I think I don't want to touch. I need to touch wood when I say this because I always tempt fate. But the new trains, compared to the existing, they've got far more redundancy built into them in terms of the power setup within the train. So there is infinitely more reliability within them than you're going to have within the existing fleet. So if anything, it's probably going to be the new trains recovering the existing trains. And as I say, we'll have the coupler adapters there to help if needed.
Good, thank you. Okay, so there's a couple of linked questions going back to the energy story for a moment. So from John Evans of Alstom and from John Harding. Has there been any consideration of using reversible substations to allow regenerated energy to be fed back into the grid? And are the trains capable of regenerating?
Fantastic question. If that's the John Harding, I know I can understand why he's asking that. So, hello, John. Long time no speak, and I've still not seen you, but long time no speak anyway. The challenge of reintroducing into the grid, and whether or not that makes you a supplier, and whether or not you need to fall under certain other parts of legislation, is an interesting one. So I've looked at that in the dim and distant past. I think what people are favouring these days is line side energy storage. So whether it be batteries, whether it be supercapacitors, whether it be a mixture of both, and charging through regenerative braking on the trains and charging at the line side storage, and exploiting the energy that you recoup by putting it into the grid at the times the grid needs it most, i.e. when everybody switches their kettle on after the World Cup final and things like that at half time. So that is where I think money can be made, and schemes can start to pay for themselves and wash their face, rather than just pushing it back into the grid as and when. So that seems to be where the thoughts are heading in terms of energy recuperation. Certainly our new trains will be capable of regeneration, and we will be relying on that as well to regenerate, and we'll be using that ourselves within the network as much as possible. And we've done all sorts of nice modelling to show how much energy we will reuse on the network as part of the normal timetabled operations. So we will regenerate and reuse an awful lot of energy from these new trains. So that is something that the existing fleet doesn't do, as John will well know, something that the new fleet will do. As for exporting from substations, you could never rule it out. I think it really depends on which way things are going there. And again, Newcastle University has got a centre set up which is looking at this very thing. So I think one of the questions once the new fleet is up and running is, okay, so how can we start exploiting this? Because energy prices are only going to go one way, and we need to think about whether or not we can reduce the bills, or perhaps even generate some form of income.
Okay, grand. So I've got a question from Pearl Hadgery. So what are the arrangements for endurance running prior to entry into service?
Endurance running. So, okay, I'll try and answer this. I'm not familiar with the term endurance running. Perhaps I should be. You've got us worried now.
I think probably aimed at proving reliability before acceptance of the train.
Okay. Yeah. Right. So in terms of endurance running, we've specified 2,000 kilometres between technical incidents to get through to the provisional acceptance stage. So they need to clear that. It will reset for any fault, and during the contract negotiations, Stella didn't manage to tell us what a fault was and what a fault wasn't. So it is any fault that impacts on service that will reset the clock to 2,000 kilometres per technical incident, and they need to get through that barrier before, as I say, we'll get the provisional acceptance. However, the longer term target is 60,000 kilometres per technical incident, and that is at the fleet level. So we have a milestone in the programme called fleet acceptance, and fleet acceptance has a rather large bond attached to it as an incentive to the manufacturer to make sure that they get there. And 60,000 kilometres per technical incident is one of the conditions of fleet acceptance, and that occurs, I think, around about 18 months after the last train's delivered. So we're probably looking at towards the end of 2026.
Mm-hmm. Yes, as you said, it's considerably better than the current fleet can manage.
It is considerably better than the existing fleet. Yeah, quite right, Louise.
Okay. From Andrew Frodsham. I'm sorry, Pearl, I hope that answers your question. If not, perhaps you could follow up using the same question box. From Andrew Frodsham. Yeah. There's now a full width cab. Will the passengers be able to see fore and aft? One of the features which makes travelling on the metro the most pleasurable.
Yeah, this is one of the sacrifices, unfortunately. Andrew. It's certainly something that we know a lot of customers are fond of, the view out of the front of the train, and it's quite novel. It's not exclusive. Other trains do have that view as well. What Stadler have proposed as a monitor to look out the forward-facing CCTV out the front of the train, and they'll be able to look through that, and they'll have a monitor. Whether that achieves the same thing, we don't know. We think it's quite a nice touch, and it reflects the fact that Stadler, really got the system during the procurement. They were out there, they were looking around, they knew what people liked and what people didn't like, and they put this into the design. So it was a nice touch, and I think it's the best we can do with the full width cab, unfortunately.
Okay. So Anne has followed up her little question about reliability with something that follows on, I think. So is all reliability... That's right, I'll start that again. Is all reliability growth planned to occur on the railway? So I think that's a question around, will there be, what's the sort of reliability growth approach that Stadler are adopting in order to meet that 60,000 kilometre full acceptance target?
Yeah, it will. So the 2,000, just to clarify, before we reach provisional acceptance, that will be done out with passenger service. So that will be threading the trains in between normal timetable trains to get up the 2,000 kilometres. We'll be simulating passenger service, so we'll be stopping at stations and opening and closing doors and all good things like that. But the 2,000 won't be with passengers on. The 60,000, however, will be. So that will be in the real environment.
Okay. And do you think what do you know what sort of process Stadler has for reliability growth in addition to just running the trains up and down and seeing what happens?
Yes, so we're getting into that at the moment, Louise. So really, really interesting. Not sure how much I can say from a intellectual property perspective, actually. So I'll need to be careful. I'll need to speak to a lawyer before I answer that one. But ultimately, the information that the data that the trains are giving us and feeding through to the systems and predicting issues before the manifest, that's going to help. But undoubtedly, we're going to go through the same pain as a lot of other operators, where software will be probably the thing that causes us the most bugbears. Software and firmware updates until we get that right, especially during the initial phases, and perhaps even beyond there into the operational phase. Once the trains are started, we'll start using them in anger. But they do have systems, processes, plans in place. We've got lots of plans, as you can imagine, and certainly we'll have a plan called a reliability growth plan, which has all sorts of interesting processes in there as to how they will achieve the rate of climb on the reliability growth that we require to get to the all important fleet acceptance. To be honest, I could probably do a presentation alone on reliability growth, because it's a huge area of well-defined processes, but also some perhaps unique to Stadler as well, which would probably be of interest to the group. It's a fascinating area.
Perhaps we'll put that one on the list for next year then.
I might bring Stadler along to help us out with that one as well, Louise.
Perfectly fine. Okay, so there's another question from Derek Rayner. Moving these trains through Europe and in the UK will presumably require 2 barrier vehicles in order for the units to couple to the locomotives and allow the brakes to work. Do we know who will produce and own these?
Not yet. So that is something that plans on that are being worked up right now. So we're still still a couple of years away from requiring that. So I'm acutely aware that sometimes it takes that long to plan these things, but we're still a couple of years away. So they're in the procurement. Stadler are in the procurement phase for the whole year as we speak. So those plans haven't been firmed up. But yes, I'm aware that we'll need the barrier vehicles and the locomotives, coupled to the locomotives, sandwiching the new train in between when that move's made.
Okay, good. Right, we have a little bit of time left for any more burning questions if anybody would like to ask them. One of the questions that interests me at the moment, clearly we're suffering, or the railway industry is suffering at the moment with a lack of patronage caused by COVID. I don't think any of us really knows how patronage is going to recover. If there's at what point COVID will end and things will start to return to whatever the new normal might be. How is must have been a business case for those additional 4 units that you've decided to take the option up on. What sort of patronage levels do you think you need to make that business case sustainable compared with the current levels of the levels of patronage prior to COVID?
Yeah, I think as with all good transport business cases, journey time has a far greater weighting in the business case than patronage does, Louise. But it is important. It's without a doubt. I mean, certainly when we submitted the final business case for the fleet, we were at a base of almost 37 million per year, and well, if I wind the clock forward to next year and look back over the year we've just had, it's probably going to be somewhere around about 40% of that figure at the year end. So it has been catastrophic. It has been catastrophic, and it is an important consideration for those business cases. Now, we do have to still submit the final business case for Metro Flow to the DFT, and that will be July of next year when the final business case is ready to go into DFT. You may have seen or heard that we've started the procurement process to find a contractor for Metro Flow for the track dueling there. And the test will be whether or not that drop in patronage does actually impact on flow. Now, it all depends on the recovery plan and how quickly patronage can return to, if not the same levels we had prior to March 2020, but similar levels of patronage to that, because I think we all know, we're sat in the houses working, and that will continue for some, regardless of whether we dispose of COVID issues or not. I think people's working arrangements, shopping habits, all of that will be changed forever, I think, at this stage, and that's already probably happened. So I think certainly in terms of our forecasting, we are not forecasting any time within the next 2 years to be getting back to the patronage levels we had prior to March of this year. That will need to feature into any business case we produce for route extensions, for Metro Flow, and everybody's going to be in the same boat. So in terms of the BCR washing its face with, because that's what would happen. Your value of benefits would reduce if your patronage is reducing. I think the Treasury and Treasury Green Book principles that we refer to when we're developing business cases, I think the Treasury Green Book principles are going to have to change on the back of COVID, if I'm perfectly honest. And I think some of the weightings which may penalise you for a reduction in patronage are going to have to be adjusted. That's the only way I can see any scheme in the UK passing muster in the business case stage, because every scheme in the UK, certainly in rail, is going to be impacted in the same way.
And I think the important thing we must lose sight of in that is that whilst we might be in the grips of a COVID pandemic, we're also still in the grips of a climate emergency. So worsening our carbon performance by encouraging more people to use road vehicles is going to be a climate disaster if we can't get those Green Book evaluation criteria changed.
I think so, yes. And certainly that's a local issue within Tyne Wear as well. You know, just before COVID, all the headlines were about taxing vehicles across the bridges in Newcastle. And that sort of, those headlines dwindled with the onset of COVID, but those headlines are starting to come back. You know, this hasn't gone away, and if anything, it's getting worse because more people are choosing the car as their mode of transport because they don't want to be mixing with other people on public transport and various other pressures and reasons why they're turning to cars. And of course, we've went from a stage where we're in a climate emergency to fast approaching that same stage, if not surpassing it, over the next few months.
Yeah, I agree. Right, well, I think that concludes the questions. I've not got any more waiting for in the inbox, so thank you very much, Neil. Emma, could you put that slide up with the web links again, please? Super, thank you very much. So it falls to me to do the vote of thanks to Neil. You and I have known each other now since 2013, I think, one way or another, Neil, and you've not changed a bit in that time. You've always been very helpful, very open and straightforward, and you've shown that again this evening. So thank you very much for doing this and taking time out of your schedule. I think it's been an excellent presentation. We've had some excellent questions as well. And I think I'd characterise the whole project as enterprising. There's a whole series of things throughout which lead me to that conclusion. So there's an enterprising engagement with the public, both at an early stage in developing the specification and at a late stage with finalising the public-facing aspects of the new trains. There's an enterprising engagement with the drivers over the cab design currently. You might have been forced down that road, but it might also have happened even without COVID, but you're taking advantage of that in a good way at the moment. You have the enterprising use of the site at Howden with and the enterprising approach to getting that site right. It was a risk, it was considerable risk, and I know certain people, certain projects probably would have fought shy of doing that and had a longer timescale as a consequence. Having the depot at Gosforth and keeping it there was, I'm sure, done for good reasons, but it has made the project more complicated. The trains themselves have some novel features that people won't be used to yet. Certainly the depot maintainers are used to articulated trains, but not this many articulations in the train, so that will make life interesting when they get hold of them. To deliver them by rail is enterprising, and I'm delighted to see that that's the route that Stadler are taking. I'd like to hope I had something to do with some of the features that have come in on the new trains, having done a little work with Stadler in the process, but you can never quite tell how much of it is down to anybody's individual contribution. But clearly a very large amount of the outputs that we're going to see in the coming years are down to Neil's personal contribution to this project and this program. So thank you very much from me personally. I know it's thank you from everybody else who runs the North East Centre, and to our audience this evening. I'm sure they will also be thanking me, or thanking you rather, for the quality of your presentation and the quality of and depth of the answers that you've provided to us as well. So by way of thank you from me, I can't do a full audience clap, but congratulations and thank you. By way of a reminder for our audience, our next Northeastern event will be Professor Felix Schmidt, recently retired from the University of Birmingham. It's his chairman's address, and it is all around systems engineering, a long history and exciting future of systems engineering, if I remember the title correctly. You can register for that in the same way as you registered for this evening's presentation. And we look forward to seeing you hearing from you indirectly on the 14th of October, or any other of the Railway Division presentations that will be coming up in the coming months, which will remain virtual at least to the end of this calendar year, and with the way things are going, quite possibly into 2021 as well. So thank you to everybody in the audience. Thank you to Neil and to my colleagues on the committee, and good night.
Thank you, Louise.